So we are focusing on the exponentials part of the cumulative. And what was exponentials? Well, an exponential is where there's an x in the exponent. So here is a typical question. You have a $4,000 balance in your bank account. If inflation is going at 5%, you're losing 5% of the value of that every year. And if I put that to the x, that is a typical exponential. All right, so now I could give you two things from here. I could either say, here's how much money your money has shrunk to. You're like, your $4,000 is only worth half. Well, then the 2,000 would go here. Or I could have said, here's how many years I want you to do. But let's do it this way, where we put a 2,000 as the end value. Remember, this is the start value. All right, and now you're going to need logs to solve this. On the actual test we took on the exponential test, you didn't know logs, but now you do. And so we can put problems like this on the cumulative test, where it's kind of a combo. First, you'd have to know how to do it because of exponentials test. And then at the end, you're going to need a log to solve it, and that's going to be from the logs unit. Okay, so we're going to start by dividing by 4,000. And I think everybody knows that 2,000 divided by 4,000 is going to work out nice. There's no reason to grab a calculator yet, because that's just 1/2. 1 minus 0.05 is 0.95, and that's okay at this point because we're going to have to use a calculator anyway. We can just change that to 0.95. And now, if this had been on the exponentials test, you would have been stuck right there. But now you know logs. So now you can solve this. It's obviously a log. When those have a base and an argument, and so hopefully you know what to do. Figure out the answer, use your calculator and logs, and I'm going to pause for a minute while you give this a shot. Okay, if it's been a long time for you, the base of this is this, so that goes here. Log base 0.95 of 1/2, and you could put that in as 0.5. You and I know that's the same thing. Then, how do you put that in a calculator? There's two ways. If you have a nice calculator with the new software, you do Math Alpha Math, brings it up the fastest. And then it's got two boxes because it's capable of subscript in that version of the software. So Math Alpha Math would bring this up, and you put the 0.95 here, and then put the 1/2 here, and then you get your answer. Or if you don't have the nice calculator, you all need to know this anyways. This is called a base change. Log of 1/2 over log of 0.95. Did you know that you could put it that way? And why do you need to know that if you have a nice calculator? Because if we ask you to change it to base 37, you do this first, and then you just put in any base you want. There, I just made this problem have base 37. And no, it's not easy to put into the calculator now, but that's not the point. The point is, do you know how to do a base change? All right, so and again, I think for some of you this is kind of new, so I'm going to give you this one more time. Let's say I said log base 4 of 8. Would you agree that that has a base of 4? Making it have a base of 10 is fairly easy. Start with that. Make this base 10. If you missed that a second ago, it's log 8 over log 4, and you can pick any base you want. If you don't write a base, what base are you really saying? 10. So what if I wanted it to be in base 10? Well, I'd just write that. What if I wanted it to be in base 7? Just put it in base 7, and it's still going to work. And I know that feels weird to just be able to change the numbers like that, but they both just scaled their answer up equally so that the ratio is still the same. All right. Okay, so that's a base change, and you're expected to do that on your cumulative test. Whether or not you have the nice calculator, if I ask you to write this thing in base 7, that's how you do it. Okay? All right. Now, why is base 10 arguably better? Because that can go in the calculator. You just type log 8, log 4, divide them, and you get your answer. Try it. Just get the answer. Let's make sure you get what this comes out to be. Do you need to borrow a calculator? Oh, you've got one. Okay, good. So type in log 8 over log 4. Let's see what you get. All right. So for this, since I wrote it that way, I'm just going to do it with log 10, enter. That's 1. No, wait, log 8. Sorry. Log 8, enter. Divide by log 4, enter. I get 1.5. Raise your hand if you had 1.5. Awesome. Okay. So that's what this is equal to. This right here is 1.5. It's just putting it in this unusual way. And one more thing. What if I had you type in ln 8 over ln 4? Effectively, aren't I just changing it to base e? And so shouldn't that work? It should. I'll be your calculator. ln 8, enter, divided by ln 4, enter. And it's 1.5 again. Huh. See, I made it base e. Does that make sense to you? I just changed it to base e. Okay. All right, that's called base change. And the kids that have the old calculators already knew that to type this in, that they'd have to know some trick, which was to put log 8 over log 7. But now you all know that, so that you can do it what's called base change. These are equal to each other. And any base I want means I could make this base 8, and I think it'll be interesting. It'll be log base 8 of 8, which is 1, over log base 8 of 7. Did you know that that was a thing? Log base 7 of 8 is equal to 1 over log base 8 of 7. Ooh, yes?
Why would it matter if you change the bases if you just do the same?
Why would it matter? Just because if you were asked to, on a test, change this to another base, like, hey, this is base 7, make it base 4. You know how to do it now. You just can say, well, I'll just make it log base 8 of 4 over log base 4 of 8 over log base 4 of 7. I'm just showing you how you can change it from one base to another base. And the most common base you'd want to change it to would be base 10, so that you could use a calculator. So the reason you care is mostly just if you were forced to use base 10 because that's the only button you had on your calculator is the base 10 kind. You could change them all to base 10. Okay, so I just freshly looked at your exponentials test, not your log one. That everybody just took the log test yesterday. I got those here, but the exponentials test. And here was the most common mistake answers. For a squared b to the third times 3a to the third b to the fourth, all of that squared, but not just squared, to the negative 2. I'll write that even clearer. Do you remember how to handle that? Logs won't save you. Just because you know logs now, that doesn't fix this at all. This is about, do you remember how to do negative exponents? And then there's also fraction exponents. We'll review all of that stuff, but one thing at a time. Everybody practice this one. There's a question just like that on your cumulative test. Okay, just a little quick reminder. Do you get that these can be done in parts? Like, you can just square everything in the parentheses, because that's part of it. And then you can do this negative power, which is part of it. It just flips it. Another way to say it is, it puts it in the denominator. And you might be like, well, there is no denominator. Well, you can always put it over 1. So this stuff is going to move down to the basement because it's a negative power. So all this stuff in the parentheses not only gets squared, it gets moved. And then you simplify it a bit. And would you please do that? And when your partner is done, compare answers with them.
So 4/9, 8 to the 4th, 8 to the 5th.
All right, the 3 gets squared and goes down here. A to the 3rd gets squared, which when you do that, when you do a to the 3rd and then you square it, I know it's -2, but I'm moving it to the denominator. That's going to be a to the 6th. And then the b is b to the 8th. And why did they move to the basement? Because of the negative power there. All right, so I have finished that part. And now I have to simplify it. Well, 4/9 can't be simplified because there's no common factors there. But the a to the 2nd on top and the a to the 6th leaves an a to the 4th on the bottom and a b to the 5th on the bottom. Raise your hand if you had the same thing as me. Okay, awesome. All right, so that's one of the most missed questions. Here's just like one of the first questions from that test. 27 m to the 3rd to the -1/3. See if you remember what to do on something like that. We're not solving it, we're just simplifying it. Remember, the roots are on the bottom, just like in plants. That's the root part. Simplify that down, compare it with the kid next to you, see if you get the same thing.
1/3. Do you want me to just so to the 1/3 power, right? 27 to the 1/3 power. That's the same as like to the 3rd root. So that's 3. And then m to the 3rd power is just m. And then because it's negative, we just drop it down.
All right, so this 27 is to the 1/3 power first. I'm not going to do the negative till the end. 1/3 root of 27 is 3. And then this m to the 3rd, and then I'm just going to separate that out and just show you for a second. M to the 3rd to the 1/3, when you multiply these two, you get m to the 1. So that's just m. And then what about this negative power? 1 over. 1 over 3m. Raise your hand if they had that one right. Okay, cool. I'm pretty sure that's right, isn't it? People are looking at the board kind of funny, so I'm pretty sure it's right. All right, so I have another one that is, you might think, well, now that we know logs, these exponentials will be easy. Well, some of them actually will be, but some of them won't, the logs won't help you a bit. A to the 8th over a to the x is equal to a to the 11th. You can't use logs to fix this. There's 2 ways you could do it, and I just thought of, you know, my favorite thing is factoring, that there isn't any factoring here, but my second favorite thing is clearing out the fractions. Do you get there's something here that's making this a fraction problem that wouldn't have to be there? Do you get if I wanted to, I could multiply by a to the x on both sides? Just bear with me for a second, see what would happen. Do you get that would cancel that? And then these two could be combined fairly easy. A to the 11 plus x, or x plus 11, either way. And then the bases are the same. Now I know some of you are like, but I did it a different way. Did you get the same thing as me? Well, let's finish, get the final answer here. 8 must be 11 plus x. I'm going to subtract 11 from both sides. I got -3. Anybody else get -3? Okay. Now, here's another way you could have done it. I'm going to rewrite the original problem. A to the 8 over a to the x is equal to a to the 11. Maybe somebody of you guys did it this way. A to the 8 minus x would be a to the 11. Did anybody do it that way? That was smart. It's a good way to do it too. Do you get that when you have exponents that are like this, you subtract them? See? And then this must be equal to this. So 8 minus x equals 11. Subtract 8, negative x equals 3, x equals negative 3. Two different ways, both of them got negative 3. Okay, next topic is about graphing exponentials. These are easier than logs. Imagine that I gave you this, y equals 2 to the x plus 5. Do you get that if you knew exactly what 2 to the x looks like, you could just move it up 5? Well, this is kind of what 2 to the x looks like. And then if I just want to move it up 5, I would take every point on it and move it up 5. And then my new answer would be like here. But that's not usually the way I tell you to do these. XY chart, very good. So everybody make an XY chart. And let's talk about that original graph had an asymptote at 0. Where's the asymptote now? Well, the whole thing moved up 5. So it's not at 0 anymore. It's at 5. So this is the asymptote starts at 0. And this is the y, no, sorry, that's the x-axis, so y equals 0. That's where the asymptote starts, at y equals 0. And then, does it move? Because sometimes it doesn't. That's how you do the asymptote. It's harder than on the log one. On the log one, you'd find whatever's on the inside that made the thing 0 on the inside. This is not, this is different. This is about, did they move the whole thing up or down? Because it starts at 0, and then, look at that. It looks like it moved up 5. So my new asymptote would be like here. It's been moved up 5. And then my graph would be like that. All right, so that's how the asymptote is found. And then I need to find some points. These are easier because you don't have to like think about what would work really nice. You just stick in 0 and see what you get. 2 to the 0 is not 0. 2 to the 0 is 1. 1 plus 5 is 6. 0 comma 6 would be a point. And you stick in 1. 2 to the 1 is 2. Plus 5 is 7. Then you put in a 2. 2 to the 2 is 4. Plus 5 is 9. And these will be pretty easy. 0, 6. 1, 7. 6, 9. And there you go. So what's different about these? The asymptote's different. The asymptote starts out as this line that goes across right on the x-axis and then it moves up or down. But the points are the same way. Just stick in numbers, see what you get. All right. Next topic. I'm going to give you a word problem and let's see if you can write the equation. A few years from now, electric cars have come down in price and you buy one and it's $18,000. But then it goes down in value a little bit because that's what cars do. They don't go up. Everybody that drives a car around is slowly the value is going down. It's just how it works. You give it like 30 years. Any of the cars in the parking lot out there are just going to be a piece of crap or they're already dead and they're like crunched up in a landfill somewhere. In 30 years, all those cars will be toast. Okay, maybe, we don't know yet about electric cars because there's no 30-year-old electric cars around. We don't know. Maybe they'll be able to just replace the batteries in them. We don't know. But if they can just replace the batteries will be really cheap by then. So maybe electric cars will go longer. Some people are saying electric cars might be 1,000,000-mile cars. It's possible that the car could just keep going. You just replace the battery and you replace the electric engine and, you know, little things like you'll have to replace tires like you always do and stuff. But we don't know for sure. But we know that gas cars, typically in 30 years, they're toast. Don't know yet about electric. But this $18,000 car is going to depreciate by 5% per year. Can you write the equation for that? And then tell me, what's it worth in 7 years? try to relate these to the real world as much as possible. That's why I take the extra minute, try to explain what I know about. Again, because you're all going to be driving cars. I'm not one of these people that thinks you won't have to drive a car. I think you're going to be driving cars for a long time. But someday, like, let's go way out into the future, when you have kids and your kids are like 18, so that's a long time from now. That's like 25 years. It is possible that people won't be driving their own cars. Like, it'll be optional. If you want to, you can shut off the computer and take over. But most of the time, I think your kids will probably be riding in cars more than driving them. We'll see. Time will tell. All right, please turn and talk to your person next to you. See if you got the same thing. All right, you should have said y equals 18,000 times 1 minus 0.05. If you said 0.5, you're doing 50% depreciation. 0.05 to the x, and x was 7, so I put a 7 right there. And then that all could be done on a calculator. And Hakan, what did you get?
12,570.07.
And somebody could be off because maybe they rounded differently, but if we round it, would you guys agree it would round to 12,570? Okay, cool. So why did your car go down in value? Just because over time, when somebody's going to go buy a car, do they want to buy yours? Not as much as they'd rather have a new one. So then new ones are worth more than yours. Makes sense. All right, let's go to the last thing that you'd have to know. And that's solving things where you have this weird mix of square roots and powers. Let's see if you can solve that. This is from the exponents test. You aren't going to find yourself using logs at all because, you know, like that's a different test. Now, I will say that on the cumulative, if you have a problem that was on the exponentials part, but you can use a log now because you know how to use logs, you can use that new knowledge that you have. If you can solve a problem with a log, you can do it. We're not going to be like, no, illegal. If you can find a way to use a log, use it. You just got to show your work. I think you all know we're going to start by adding 5, right? I hope you all know that. If you didn't know that, fix it. Then here's the real separation is some kids will know how to make this into a fraction exponent that then simplifies. And some kids won't. Do you know what power this really is? Would you agree that you could construe this as a fraction power, and that's a 2? If you forgot that deal, if there's a square root and there's no number there, then there's really a 2 there. It's kind of like the default. It's kind of like a log that has no base is base 10. Square root that has no number there is a second root. So the 2 goes on the bottom there, and this 4, that goes on the top. That's like a normal power. That's like a root power. Roots go in the bottom, just like in plants. And then, of course, that can be simplified to 2, because 4 over 2 is 2. But then, Omen, do you know what happens next?
You square root both sides.
You are correct.
Square.
And what special thing happens because you did that?
25 goes to 5.
That's true, but that's not what I was talking about. There's something special that happens right now.
Oh, plus minus.
Yes, because this is an absolute value, you do a root that's even on both sides. Remember that deal? That came up. Always does, because we're trying to make sure you remember to not lose a solution. Otherwise, you'll just get one answer when you're supposed to get 2. So I don't want you to put a plus minus right there until you've done the absolute value, because that's what's really happening. The square root of 25 is not two things. The square root of 25 is just 5. The reason there's two things is the absolute value. X minus 4 is 5, and x minus 4 is negative 5. That's what absolute values do. So your final two answers would be x equals 9 and x equals negative 1. Now, I'm so sensitive to these negatives now that I'm starting to think, is there a chance that that one's extraneous? There's a chance. So I would go up and see if these actually work in the original problem. If I put in a negative 1 right here, does that like break any rules? No, because this fourth root, or sorry, that power of 4 would cancel off the fact that it's negative. So it's not a square root of a negative. So then we're safe. So that negative 1 works. Because this power of 4 right here changes that back to a positive number before you take the square root of it. So I double checked and both of these answers work. So it's got two answers. That's definitely one of the hardest kind. And the last thought is base changes, and that goes like this. 16 is a typical one we use. To the 2x is equal to 1/4 to the x plus 1. If you could just make the bases the same, this will be easy. But you might be like, how do I make 1/4 into a 16? That's going to be weird. Or how do I make a 16 into a 1/4? That's going to be weird. So, John Paul?
Negative 2.
So what do you want to make into what?
I was going to make the 16 into 1/4.
Into 1/4. That's legal if you can figure out the power. 1/4, and then I'm just going to bring down my 2x. But 1/4 to the what right here? That's critical.
It's either negative 2 or negative 1.
Well, would you agree that putting it to the second will make my 4 become a 16?
Oh, yeah, but to the, one, we have to flip it.
We want to flip it, so we want to make it negative. So it was negative 2. You had two choices there, and the negative 2 was the right one. All right. Now, he made it be a 1/4 base. Could you have done it by making these both into a base of 2? Yeah, that's how I probably would have done it. But he fought through it, and he figured this out. So I would have just done 2 to the 4th is 16. And then it's to the 2x. And then a 1/4, I still had to have a little work there. It's 2 to the, well, I want to make it a 4, so that's squared. But it can't just be squared. Oh, negative 2. And then the power is still x plus 1. So I'm going to do it that way. And my final answer will come out to this has to equal this. 8x has to equal negative 2x, and I'm distributing this, minus 2. And then I can solve that all day long, 3 times on Saturday. Okay, moral of the story, got to get the bases the same. All right, there, we've covered pretty much everything you'd need to know for that part of the test. Now, what about logs? We're going to cover that on Monday. And then the cumulative test is on Tuesday. Now, I want to make sure you get how important this is. Imagine, do you have a straight A right now? It's only important because you had an A on the last 2 tests, and this next test counts, whether or not you needed a retake. And if you just kind of blow it off and you end up getting a B- on this test, then you have 2 A's and a B-. Okay? But do you get there's a lot of kids that didn't do well on at least one of the 2 tests? So imagine that you have a C on one of the 2 tests. Then this third test becomes huge because on a cumulative test, at that moment, if you pull off the A, it could change that into an A, and now you got 3 A's. It's huge. So don't underestimate. Tuesday's tests can totally change your semester grade. If you get a really good grade here that can fix any mistakes you made, it matters for everybody, but man, when you can possibly change 3 tests in the grade book to an A, it's huge. Don't underestimate this cumulative. All right, so now what are we doing? I'm going to hand back your tests, and you're going to do corrections on it if you need to, and a lot of you won't need to. Then what do? Your homework is there's two worksheets, one's for today and one's for the next time, and we're called part 1. You're gonna open up the worksheet. Please do this right now. Open up the worksheet called part 1. Now, there's a lot of problems on there. In fact, I would say there's too many problems on there. If I just assign them all, I'm afraid you're gonna like get overwhelmed and not do it. So I'm going to assign half of it, but you decide what half. Like you can literally, you don't have to pick evens or odds. You can just go through and go, too easy, too easy, too easy. Ooh, I should try this one. I haven't done it in a while. Now the people who are weak are gonna just go and pick the easy ones and do that half. Okay, that's not gonna help you prepare for the test at all. You already know how to do the easy ones. So pick the harder ones and do those. Pick the harder half, but it depends on the kid, which half is harder. Okay, so take part 1 and do half of it. Do the part that scares you. Because you have a key, you can check it. No, if you want to do a few that are easy just for the fun of it, go ahead. But, pick the harder half for you. It reminds me of a quote from medical school. When you get done with medical school, they tell you, we know that half of what you just learned is wrong. We just don't know which half. Why? Because everything in medical school, like half of it's wrong? Well, there's a lot of things that they think are right, and then they're going to turn out later to be wrong. Like, first doctors, not even the first doctors, like, even just 100 years ago, doctors were telling people that were things that were completely wrong. They just didn't know it was wrong. They thought it was right. Things, like, they just don't know. Well, anyway, so that just quote is kind of a famous quote about med school. Half the things you just learned are wrong. We just don't know which half. And so you're about to take a test, and I'm suggesting you do half of the worksheet. You should do the part that you think you're going to get wrong. Okay? So we'll practice those. All right. And if you want this thing to count as a retake, you have to do corrections. So take the time on today or Monday to do corrections on the part that you bound. That's all I got for you for today.